Hello, I'm Tracy Grimshaw. Welcome to a special edition of A Current Affair,
where we bring you breaking news about the continent of Antarctica. Today we will delve into the question of how and why Antarctica became a continent covered in 30 million cubic kilometres of ice. We go now to an interview with foremost paleoclimatological Antarctic expert Atticus Phillips, who will be interviewed by Current Affair veteran journalist Clifford Cooley. You may remember Cooley from stories such as Ham, Scam and Pensioners at War, but this interview is arguably more insightful.
Thanks, Tracy. I'm joined by Dr. Atticus Phillips, an expert in paleoclimate reconstruction in the Antarctic region. Mr. Phillips, how are you?
Sublime, thank you.
Now, Doctor, the question on the nation's mind, how did Antarctica come to have 30 million cubic kilometres of ice?
I'm glad you asked, Clifford. May I call you that?
Mr. Cooley is fine.
Well, Antarctica has been located in the polar latitudes since the early Cretaceous period, around 140 million years ago. It only became dominated by ice sheets around 34 million years ago. We think that the sudden glaciation comes down to a few factors. Plate tectonics have shifted Antarctica to a higher latitude, in tandem with a reduction of CO2 concentrations and ice albedo feedbacks further cooling the continents.
So I'm reading here that we know this because there was a measurable rise in delta oxygen 18 values in deep sea sediments, ice rafted debris and fossils of Antarctic vegetation, all indicating a temperature drop. But why did that happen?
Yeah, that's a really good point. The first theory to explain ice sheet expansion in Antarctica is the gateway hypothesis, which basically says that as Antarctica became thermally isolated, it broke away from Australia and this coincided with the formation of the Drake's Passage between South America and Antarctica. This deep ocean environment allowed for a westerly current of cold polar water to block the transport of warmer equatorial water moving south. This is known as the Antarctic Circumpolar Current. Before this thermal isolation 34 million years ago, proxy records have shown Antarctica to be ice-free.
Wow, so I guess you heard it here first, folks. Thanks for your time, Phillips.
Whoa, hold up now. That's not the whole story. CO2 concentrations also were a significant factor. Around 66 million years ago, CO2 levels have been modelled to 2 to 5 times above present values. That's concentrations around 2,000 parts per million. CO2 values declined between 55 and 40 million years ago, and fell below a threshold value estimated to be 750 parts per million around 34 million years ago.
So all it took was a drop in CO2 in the circumpolar current?
Not quite. The cooling from declining CO2 concentrations would have gradually lowered annual snowline elevations below Antarctic topography, allowing for ice albedo feedbacks to initiate rapid ice sheet growth.
What caused this drop in CO2?
We think it could be due to the increased ocean productivity from upwelling associated with the opening of the Tasman Seaway. Other research suggests that there was increased deposition of carbon on the ocean floor.
Okay, thanks for that. It definitely is a complex topic. Back to you, Tracy.